Welcome to The Explainer. Today, we've got a real cosmic detective story for you. It all unfolds about 250,000 miles away, but the culprit? Well, the culprit is a lot closer to home. We're talking about how our very own planet is chemically changing the face of the moon.
So, this all kicked off when scientists were digging through data from the moon's poles. They spotted a chemical signature that it didn't make any sense. Based on everything we thought we knew about the moon's environment, this should have been completely impossible. It was a total mystery.
You heard that right. It's rusting. The exact same process that attacks old cars and forgotten tools here on Earth is somehow happening on the surface of the moon. And that discovery, well, it flew in the face of all the science and kicked off a massive investigation to figure out how.
Okay, let's break this down a bit. To really get why finding rust on the moon is so wild, we first have to talk about what you actually need to make rust in the first place.
The specific stuff they detected is a mineral called hematite. Now that's just a fancy name for a very common type of iron oxide, which we all know as rust. And making it is kind of like baking a cake. You need a very specific recipe, and for this recipe, the main ingredients are iron, oxygen, and water.
And this is where we hit the heart of the problem. The moon. It's got tons of iron locked up in its rocks. So ingredient number one, check. But it has pretty much no atmosphere, which means no free oxygen, and there's definitely no liquid water just hanging out on the surface. So it's missing two of the three essential ingredients. How in the world can it be rusting?
Well, since the moon clearly couldn't be doing this on its own, scientists had to start looking for an outside accomplice. And all the evidence started pointing to one very shocking suspect: our own planet, Earth. Now, I know what you're thinking. That sounds nuts, right? The moon is separated from us by this huge, empty vacuum of space. How could a gas like oxygen possibly make that incredible journey all the way to the lunar surface?
Well, it turns out the secret is Earth's magnetic field. You see, as the solar wind streams past our planet, it stretches our magnetic field way out behind us like a giant windsock in space. Scientists call this the magnotail. And this tail actually traps oxygen ions that escape from our upper atmosphere and funnels them deep into space. And here's the amazing part. For about 5 days every single month, the moon's orbit takes it directly through this stream of oxygen. It's like a cosmic delivery highway.
But just getting the oxygen there is only half the story. There are still a couple of final pieces to this puzzle. For one, where does the water come from? And maybe more importantly, how do you deal with a major cosmic force that should be stopping rust from ever forming at all? Okay, this is where it all comes together. So the water, it comes from super fast-moving dust particles that are always hitting the moon. They slam into surface ice, and that frees up water molecules to mix with the lunar iron. But here's the bigger twist: the solar wind. It's a constant stream of particles from the sun, and it's full of hydrogen, which is basically an anti-rusting agent. It prevents rust. However, for those 5 days a month when the moon is passing through Earth's magnetotail, our planet physically blocks over 99% of that solar wind. It creates this perfect temporary shield. So you have this amazing little window where the rust preventer is gone, right at the exact moment the rust causer, our oxygen, arrives.
So once you piece all that evidence together, the mystery oxygen, the surprise water source, and Earth acting as a planetary shield, you land on a pretty stunning conclusion about our relationship with the moon.
What this all means is that our planet isn't just a passive neighbor to the moon. We're an active player in its ongoing story. We are literally delivering the key ingredient needed to change its chemistry, helping it rust away ever so slowly.
This quote from one of the lead researchers really hits it home. For so long, we've kind of looked at the moon as this geologically dead, unchanging rock. But this discovery shows that it's actually part of a much more dynamic system, still being influenced and chemically changed just by being so close to Earth. And that's the thought that really sticks with you, isn't it? This was happening right next door for billions of years, and we're only just now figuring it out. It just makes you wonder, what other hidden, subtle connections are playing out between planets and their moons all across the solar system and beyond? It's a beautiful reminder that even in our own cosmic backyard, there are still some profound mysteries just waiting to be solved.